do some review on finding the area of composite figures. Composite means it's composed of one or more different figures. So in this case, we have a trapezoid and a circle inside the trapezoid, and we're asked to find the shaded portion. So the way that we would set this up would be to find the area of the trapezoid and then subtract the area of the circle. So the area of the trapezoid, there's a formula for that. The area of the trapezoid is just the height multiplied by the sum of the bases divided by 2. Or you can divide it into 2 triangles and use that instead. But it's easy to just use the formula. So let's do that. So first of all, the height must be the perpendicular height. In this case, we can figure that out from the radii. This radius is 4, which means the diameter of the circle must be 8. So the height of this figure is 8. So I'm going to take 8 and multiply it by the sum of the bases. So that would be 8 plus 11, which is 19. And then I divide that by 2. And I can cancel the 2 and the 8. So that would be 4 times 19, which is 76 centimeters. So I know the area of the trapezoid is 76 centimeters, and now all I have to do is subtract the area of the circle. The area of the circle is just pi r squared, so that would be 16 pi centimeters. And so my answer is simply 76 minus 16 pi, and then I put parentheses around it to indicate that these are both in centimeters. Now for number 7 here, we have to find the area of this figure, but it looks like a chunk was bitten out of it, and the chunk is a semicircle. So what we need to do is, again, if I drew a line here clear across, I would have a trapezoid. So what I could do is take the area of the trapezoid and subtract the area of the half circle. So area of the trapezoid minus the area of the half circle. I'll just draw a little half circle there. So again, the formula for area of a trapezoid is just the height, 17, times the sum of the bases. So this base is 37. This base is actually going to be 20 because it's the length of the diameter. So we have 20 up here. So 20 plus 37 is 57. And then we would divide that by 2. So we would get, let's see, put that into a calculator or calculate it by hand, we would get 484 1/2, or 484.5 if you prefer, for the area of the trapezoid. And now we find the area of the half circle, which is just the area of a circle divided by 2, so pi r squared over 2. So the area of the half circle is 100 pi over 2, which is just 50 pi. And so to figure out the whole thing, it's just this minus this. So that would be 484 1/2 minus 50 pi. And our units are in inches squared. Actually, this centimeter is centimeters squared also, because we're talking about area. So sorry, I forgot about that. So one more example of a composite area here. We have the area of the shaded portion on number 9, which is a parallelogram. And a parallelogram, you can find the area of a parallelogram. So we'll do area of parallelogram minus, this one's a little more complex, area of a parallelogram minus this half circle. So I'm going to put parentheses and say the area of the half circle, I'll put H for half circle, plus the area of its triangle. So we need to find all these separate elements here. So the area of the parallelogram is the easiest part to find, because the area of a parallelogram is just simply base times height. So the base is 28 and the height is 20. So we have 28 times 20. And then we're going to take the area of the half circle, which is area of a half circle is pi r squared over 2, so that would be 81 pi over 2. And the area of the triangle would be 15 times 18 divided by 2, which would be the same as 15 times 9. And by the way, I wanted to mention another way of doing this. This is basically the parallelogram minus the sum of the half circle and the trapezoid. But another way to write this, if you distributed the negative sign, it's another approach, but it's the same thing. It's the area of the parallelogram minus the area of the half circle minus the area of the triangle. So these are the same. Just wanted to mention that in case you think that approach makes more sense. So now we can multiply 28 times 20. So 28 times 20, and then we're going to subtract 15 times 9 from that. So 28 times 20 is 560 minus, let's see, 81 pi over 2 again, minus, now that I distribute the negative sign, I'm subtracting 15 times 9, which is 135. So now the two like terms here can be combined. So I have a regular number here and a regular number here, and this one has pi in it. So 560 minus 135 is 425. And 425, and then I still have the 81 pi over 2. Which you could write that as a mixed fraction if you want, or as a decimal if you want, but it's fine like that. And then it's in feet squared. So you could, you could write it as 40½ or 40.5 if you prefer. So that's how we find the area of composite figures. We have to sort of come up with the master plan at the beginning and then follow through on all of the little steps in between.